Derivatives of trigonometric functions. In this video, you will learn how to find the derivatives of the 6 trigonometric functions. If you had forgotten about the properties of trigonometric functions, then before starting this video, you may need to review trigonometric functions by watching the videos that appear in the upper right corner. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It is very important for the continuity of this channel. We begin our discussion of the derivative of the sine function by considering the following limit. Let us investigate this limit using the geometry of the figure below. Let x be a number positive between 0 and pi over 2. When x approaches 0, we can write that x is between the sine of x and the tangent of x. Dividing each term by sine of x, we get, which by taking reciprocal yields. Now we take the limit as x approaches 0. The function sine of x divided by x is squeezed or sandwiched between the values 1 and cosine of x. And since the cosine function approaches 1 as x approaches 0, one can say the limit of the function sine of x divided by x must also approach 1. And so we can write this limit as follows. To find the derivative of the sine function, we use the basic definition of the derivative. We now use the following trigonometric identity. We divide the numerator and denominator by 2. We now use the limit on the side to get the derivative of the sine function. To find the derivative of the cosine function, we use the basic definition of the derivative similar to that for the derivative of the sine function. We use the same methods as in the proof of sine function. Pay attention. The derivative of the sine function is the cosine function, and the derivative of the cosine function is the negative sine function for all x in the following interval. Let's see how it works. Find the derivative of the following functions. To differentiate item A, we use the chain rule. Then we use the formula above to differentiate the sine function. To differentiate item B, we use the product rule. Then we use the derivative formulas for the cosine function and the exponential function. Before differentiating item C, we should rewrite the function as follows. We now differentiate item C by using the chain rule. We can't finish this quickly because we have to differentiate another composite function. Then we use the rule along with the derivative formula for the cosine function. We now plug those things back in and we get the whole differentiation. The derivative of sine is the cosine, and the derivative of cosine is minus sine. For differentiating all trigonometric functions, these are the only two things that we need to remember, because the remaining trigonometric functions can be obtained from the sine and cosine derivatives. Since the remaining four trigonometric functions may be expressed as quotients involving sine or cosine, we can use the quotient rule to find formulas for their derivatives. Let us find the derivative of the tangent function. We begin by expressing the tangent of x as the quotient of sine of x and cosine of x. We now apply the quotient rule and then we use the Pythagorean identity to obtain the derivative of the tangent function. The derivatives of the remaining trigonometric functions may be obtained by using similar techniques. Let us find the derivative of the cotangent function. We begin rewriting the cotangent of x as the quotient of cosine of x and sine of x, and we use the quotient rule. Let us find the derivative of the secant function. The secant of x is 1 divided by the cosine of x. We now use the quotient rule. Let us find the derivative of the cosecant function. The cosecant of x is defined to be 1 divided by the sine of x. We now use the quotient rule. You should try to solve the next examples yourself. Then check out the solution.